Okay, this is just a quick little video on translating some basic math expressions into words. So here we have a question with uh, some various expressions written out, and notice that they have told us we don't need to spell out the numbers. So if you have the number 5, you don't need to go FIVE. You can just write the number 5, but it's writing the rest of what's going on there in words. So in this first one, we see it's 27 plus 23. Well, quite literally, we're going to simply change that plus sign into the word plus. So 27 plus 23. That's all it's asking for there. Next one, we remember that with those brackets, when the numbers are written in brackets and put right beside each other without anything in between them, what it really means is multiplication. So the simplest way to write this one out would be 20 times 25. And just as a quick aside here, so there's 20 times 25 can be written like that. There's a bunch of other ways we can write multiplication. We can put the good old times sign in between, and that would mean the same thing. Also, you might sometimes see this dot used, so that 20 and then that little black dot in the middle, 25, that also means 20 times 25. Or a different way with the brackets, where even if it was just one of the numbers in brackets and the other one right up against it, that still is considered multiplication. So all of those are different ways to write 20 times 25. On the next one, that slash there is one of the ways we can represent division. So that says 46 divided by 12. That's probably one of the less common ways and has sort of become more common in the age of computers, because that's the computer symbol that we use for division. So like that is one of the ways. The more common would probably be the division sign, like so. 46 divided by 12 would be the same thing. Or as a actual proper I was going to say a proper fraction. That's actually an improper fraction because the top is bigger than the bottom. But my point was written as an actual correct fraction, not with this sort of fake slash version over here. But they all do mean the same thing. All of those mean 46 divided by 12. And then for the last one, it doesn't bother us any that they are letters instead of numbers. Letters we call variables in math, and they're simply numbers. We just don't know what they are yet. So this says a minus b, and that's all you got to put for that, a minus b, like so. Let's do one more here. This one getting into what we would call inequalities. There are 3 different ways to show an inequality, because two numbers, you might say over here on this last one, you might just say they're not equal to each other. That's one way to represent an inequality. Or you might get more specific and you might say that the one is smaller than, less than the other, or greater than. So make sure you're clear. You might have learned in elementary school the old alligator eats the bigger number. That doesn't really help very much here. You need to be able to read this from left to right. So if it starts small and gets big, that is the less than sign. That means the thing on the left is less than the thing on the right. If it starts big and gets small, that is the greater than sign. That means the thing on the left is greater than the thing on the right. So up to here, we see start small, gets big. So that is the less than sign. This says 21 is less than 34. So let's put that into words. Just like it sounds, 21 is less than 34. Which is true, by the way, right? 21 is a smaller number than 34. This next one here, this simply says not equal. 13 is not equal to 15 minus 12, which is certainly true. And that's how we would write that out. 13 is not equal to 15 minus 12. This one here says this is the greater sign, so 4 is greater than 5 divided by 2. Let's write that out. 4 is greater than 5 divided by 2. And the last one, again, we see a variable, but that doesn't bother us. Let's just read it out from left to right. X plus 7, and then we're going to say is less than 9. And what that's going to mean is x is going to be able to be any number that would make x plus 7 less than 9. So for example, x is 1 would work because 1 plus 7 is 8, which is less than 9. X is 1.5 would work because 1.5 plus 7 is 8.5, which is less than 9. But x is 3 would not work because 3 plus 7 is 10, which is not less than 9. Also, x is 2 wouldn't work because 2 plus 7 is 9. 9 is not less than 9, right? So that's how we would interpret that phrase in terms of how it affects what x can be.